Cool. Good evening, guys. I am Mankaran. So I started this project called Flowdrive. 2 years back, we were three people. Now it has grown to a community of 1,000 people. So we basically train foundation models for self-driving cars, and we are now recently moving to training foundation model for general-purpose robotics. So can we have the presentation? Yeah, cool. So talking about self-driving cars, right? So there have been three approaches which the industry has been trying. So the first one is the classical one. So this doesn't involve any machine learning, deep learning. It's just basic mathematical formulations. For example, like edge detections and all. So this method hasn't proven anything and like isn't used in the industry. So the second one is basically uses machine learning. The whole task of self-driving cars is split into multiple phases. For example, object detection, lane line detection, then drivable path detection. So this has been on mostly on the trend, but billions and billions of dollars have been poured into this industry. People have been like, and still it's going nowhere. The third one, the end-to-end approach, this one is seems very promising. So here you do not do any object detection, any lane line detection. The model takes in the image and it directly predicts the path where the human is most probable to drive. So in the demo you can see it's by Comma AI. It's from the open palette software. It doesn't do any explicit object detection. It just sees the scene, and it's very similar to how humans actually drive the car, right? We do not do any object detections, draw bounding boxes across cars, and then like make decisions on where to drive. So first two approaches people have tried, not successful. The third approach is most of the companies have been shifting towards it. So the lesson not learned. So in robotics, self-driving cars. Uh, so if we look at the history, right? So if we just take the task of object detection, it was solved by a model called YOLO. So it's an end-to-end model. It takes the image input and it outputs the bounding boxes directly without anything in between. It's trained end-to-end. Language models, ChatGPT, it's a transformer model. It's also trained end-to-end, text in, vision in, and text out. So generative AI, all the image generators, for example, face swapping and all those sorts of stuff. This has been solved by end-to-end models, right? Where you do the task end to end and there is no in between. And I personally believe, and like there are lots of facts around it, that robotics will also be solved by end to end. So if you see any company who is like doing object detection, doing bounding boxes, you can assume that they have already kind of lost. So like this is one of the meme that we like have in the open palette community. So let's say if you solve the task of self-driving by, let's say, doing object detection. So in future, if you're detecting, if your model is bad at detecting blue cones, then you would be basically stuck in a loop of like labeling the data and then just improving your models. So, I mean, let's say there's a scenario, right, where some sort of a weird scenario where some sort of earthquake is coming and buildings are falling. So your model cannot handle those tasks, right? Because you haven't trained an object detector to detect the buildings and everything. Like these are some of the notable companies which have shifted to the end-to-end approach. Tesla recently this year they shifted to fully end-to-end approach. Comma.ai, Wave.ai. So the image you see it's from Wave.ai. They have been aggressively pursuing the end-to-end approach. It's the image in, and the green line you see is the trajectory. So there's no in between, no object detection, nothing like that. So there are, it seems easy that you are just having one model, you're taking in images and outputting a trajectory, right? But in reality, it's very hard to train these types of models. The number one blocker is the data itself. So you need at least a million lines of data for your models to be anywhere useful for like driving. Then training and iteration times. So do you know like how much money it costs to train a single ChatGPT model? Anybody? Yeah, so it's in millions. Basically, the smaller models, they are in the range of 2 to 3 million if you are going to train from scratch. So the iteration times are very high. So like if there's some bug in your training code or the training doesn't isn't successful, you lose all this money and compute and time. Uh, Fixing certain behavior of the model. So if you go for an end-to-end approach, right? So there's this input, there's this model, and there's this output. So there's no in between. So it's very hard to like fine-tune certain behaviors of models. So how many of you have argued with ChatGPT, like if it's not giving the correct answers, right? So like these kinds of things are happening in reality. Humans arguing with machines. Uh, like it's true, as we move towards the end-to-end architectures, you lose control of the fine grain. You lose the fine grain control over the outputs. So what other problems are there to be solved using this end-to-end approach, right? So anything that involves human hands, you do not see robots. It's very hard for robots to even open doors, brew a cup of coffee, or like cutting vegetables. You can think of any of the examples. For example, packaging of gifts, or like anything that requires human hands, a fine-grained control. So from the hardware point of view, it's already there. This is a recent example from Aloha. This is the project's name. So zip tie the cable, right? It has a fine grain control. Uh, so it's pretty cool to see this sort of hardware. It's very cheap, not cheap in general, but it's like $20,000, which is cheap in terms of uh, robotics context. Um, so you can see that it has very fine-grained control, and the hardware is capable to do those sort of tasks. It's being teleoperated. Soon we will be having humanoids, Tesla, Figure. All of these are working on humanoids, and the hardware is going to be there very soon. It's almost already there. The hardware is there, AI is not. So now all it's left is a software problem, how you train that specific AI model to handle these sorts of tasks automatically. So if you see similarities between robotic arm manipulation and self-driving cars, right? So self-driving is a trajectory prediction problem. Uh, Robotic arm manipulation is also a trajectory manipulation problem, and so is rest of the robotics. Uh, but there are huge challenges as to why you do not see general purpose robots running around you. The first one is obviously how do you collect data? For ChatGPT, for all these vision models, all these image generation models, there's huge amount of data on the internet and it's labeled. So for ChatGPT, the whole internet is the data set. You are basically doing the task of predicting the next token. Uh, for robotics, no such data set exists. So somebody has to go there, some company has to go there and collect uh, like a bunch of data for you to train your foundation models for robotics. And there are other various more challenges. For example, for ChatGPT, you can do anything. It's fully virtual. For robotics, if your model does wrong predictions, it can potentially end up killing people because now you are putting models into physical bodies. Uh, there are other things like, for example, large language models. These are too huge to be able to run real time. Normally, for robotics purposes, your model should at least be running at 20 hertz. Large language models, these are too huge to be run real time. So there are certain challenges that need to be solved before, like, we see general purpose robots doing most of your tasks. So TensorHearts.ai, like, me and my friends got together. We are starting this up, and it's a very ambitious goal to. We have a goal to release general purpose robots and have a buy now button by the end of 2 years. So my Twitter handle is Mankaran32. You can give a follow. And yeah, short and sweet talk. Thank you.